Okay, everyone ready? All right, they overlap. Now let's look at our, because you always want to take a look at your givens first and say, do I have any sides or angles that I can put S and A over? Before I do that, let's review 5 ways to prove triangles congruent. It's been a day, 57, yeah. Here we go, 10. Give me 1 out of the 5. HL, nice. Moving on. More. 12. I'm not ranking these. I'm just writing them randomly. 8.
Side angle side.
9. And what if the side's not in between? 5. He can do it on his own. Thank you. All right, next up. Automatically eliminate one of them right now. It's definitely not this method. Why can't it be HL? It's got to have a right triangle, right? Got to have right triangles. So it's not going to be HL. All right. TR congruent to TS. Everyone look at those sides. TR congruent to TS. Can I count that as a full pair of sides in either of the triangles? Nope, it's not. So I'm not going to put an S next to it. It's not a full pair of sides. So do we understand that? It's more than a full pair. All right. These are not sides in the 2 triangles I'm trying to prove congruent. How about TM and TN? Can I count those as sides? No, they're not in the triangles I'm proving congruent. I'm trying to tell you guys, I didn't give you anything. I didn't give you any sides or any angles. So you're on your own for that. But I can use these givens to get some sides or angles anyway. All right, so take a look. Hopefully you got something in mind right now, and let's go somewhere. Anything you can tell me is congruent or what step you want to do next. Here we go, 13, anything. Subtraction, correct. I can subtract the 2 givens to get MR and NS, and I can subtract right now because I have both pairs of equal quantities. TR minus TM equals TS minus TN. Subtraction. And you guys know substitution coming up. To say MR is now congruent to NS. And now I can put a S next to that for a pair of sides. Is there anything else that you see? If not, that's fine. 4, anything else? Not here. 6, anything else? Nice job. All right, that's one. Usually a lot of people don't see that. Here's what nature said. MRS. Everyone look at that angle right here. That's in my pink triangle. Congruent to NSR right here in my orange triangle. You want to tell us why, Nate? How you saw that? See how TRS is isosceles? And what did we learn yesterday? Whatever's across from the congruent sides, the angles are congruent. Everyone see how we're getting that? So angle MRS, or you could call it TRS. It's the same angle. Congruent to angle NSR. And here's the theorem I think we wrote down 3 times yesterday. In a triangle, got to have that part. That's non-negotiable. Congruent angles, or you could put congruent sides, are across from congruent sides. And there's a pair of angles, everybody. Need one more pair of something. We're almost there, right? We're almost there. 9, see the other pair at all? Who's got 9? Remember, we highlighted them for a reason, Elion. We highlighted them for a reason. Any of your colors on top of each other? Full sides or full angles, I'm talking, not partial ones. Anything they share? Both triangles share any full angles or full sides in common. Okay, there we go. Everyone agree? RS is reflexive. It's shared by both. And there's your third pair of corresponding parts. And I think that's enough to say the triangles are congruent. What method do you have? 9 again, Elio. What method do we have? There you go. Good one. Good job, everyone. So when I say they're getting tougher, it's not because they're getting longer. They're getting tougher because I give you less and less information and you need to provide more and more. Like that one right here, you had to find all 3 pairs of parts yourself. Okay. Anything else? Okay, let's keep going. We got some good ones here today. I think these also overlap too. So if you want to grab your colored pencils, AEC and DEB, these also overlap. All right, here we go. Again, first, look at your givens. Did I give you any sides or angles? Let's see. AE and ED, can I count them as sides? AE and ED, can I count those 2 as full sides? Yes, I can. If you're having an issue with how I know if I can or not, let me know here. Let me know. Yeah, I can. Those are 2 full sides in each triangle. How about AB and CD? Mark those. Can I count those as sides? I can? Okay, ready? Answer this question for me. Is AB a full side in triangle ACE? It's not. It's not. It's a partial side, but we don't care. It's got to be a full side, so I'm not putting an S next to that. Now, that doesn't mean you're not going to use it. You're going to use it, but you can't use it as a full side. All right, so I gave you 1. You're on the hook for the other 2. All right. Before I call in the next number, some of you might think this is funny, but some of you might actually think it's a way, and I just want to squash your hopes and dreams right now. You cannot tell me a triangle is reflexive. You cannot add and subtract triangles either. You can only add and subtract segments and angles. Okay, you cannot add and subtract triangles. Please never try to do that. Great ideas, but you can't do it. Where else can I go here? 5?
Angle EAC and EDB.
Hey, angle A and angle D are congruent to each other. Why do you say that, Abbott?
It's like the one that's like in a triangle equal angles are across from equal sides.
And what's the triangle we're working with? What's the single triangle that contains the two congruent sides?
A F 7
E.
Oh, A E D.
Yeah, everyone see the big triangle is isosceles. So I look across from side EA and across from side ED, and you get angle A and angle D. In a triangle, congruent angles are across from congruent sides. Good work. There's that pair of angles. All right, let's keep searching. Remember, we have AB congruent to CD in the givens. Probably should lead us somewhere since it's not a full side. Probably should help us somehow if it's not a full side. 8, where do you want to go?
BC is congruent to BC.
Oh, wonder where we're going there. BC and BC. Reflexive. Where are we going? If I get BC congruent to BC. 3, where are we headed here? Oh, little addition. AB plus BC equals CD plus BC. Addition. And then you guys know substitution. What's that? AC and BD. And there's another pair of sides. I think we're good. All right, we're good. Method. 3 again, Spence. Spencer, method. Sorry, I didn't think you heard me. Yep, 2 sides and an angle. All good? We sure? All right, look at the proof statement in the next one. Little change up, huh? Now you got to tell me it's isosceles. All right, before we start, let's just talk. How do you know a triangle is isosceles? How do I know a triangle is isosceles? 1?
If the base angles or the 2 sides are congruent.
Okay, so I really have 2 different ways I could prove this in this proof. I could show 2 sides congruent, or I could prove 2 angles congruent. Either I don't need both. Once you prove one, that's it. That's isosceles. I don't need to prove the other one. All right, so let's prove either 2 angles in the triangle or 2 sides in the triangle are congruent. 3 and 4 are congruent. Not in the triangle, though, so I can't use them. Anybody, are we seeing what vocabulary term is going to be used here? With 1 and 2 and 3 and 4 here? What do you notice about 1 and 3? Aren't they supplementary? Everyone agrees. And what about 2 and 4? They're also supplementary. Everyone sees somehow this is going to involve a supplementary angle theorem. But if it is, you can't use one of those facts until you tell me what angles are supplementary. So that's how we need to start. 1 and 3 are supplementary. And the same thing, 2 and 4 are supplementary. Anybody remember the reason here? 8, remember the reason? Remember what these were called right next to each other? Yes, I knew you would dig deep. Good. Linear pairs are supplementary. All right, now we got to remember the theorem I want here. 1 and 2, are they supplementary to the same angle? No, but they are supplementary to the two angles that are, what do we know about 3 and 4? The congruent. All right, so if two angles are supplementary to congruent angles, they are congruent to each other. Supplements of the same angle are congruent.
Are we sure supplements of the same angle?
No, I don't. I don't know why I just wrote that because I totally just said no to that, right? It should be what? Supplements of. Thanks, Sponge. I should have probably asked you this like 10 weeks ago when we started. Is Spence okay? Or do you prefer Spencer?
I'm fine with it.
Okay. Just want to make sure. Names are important to me. What elementary school did you go to, Spencer? Eagle, nice. All 5 years you've been here? Nice. Did you enjoy your time over there?
Oh, yeah.
Good. Good times. Okay. Sorry, I'm just trying to get to know more about my students. Is that enough? Is it isosceles now? Yeah. Again, I don't need to go and say the sides are equal now. That's overdoing it. I have two angles. Boop, we're good. I know triangle ABC is isosceles. We're not going to write definition of isosceles. How do we know it's isosceles? What do we have on the diagram right now that says, hey, this is isosceles? 4? Not here. Good talk. 9? 2 angles. Ready? In a triangle, 2 angles congruent implies I have a. I think I'm going to fit. Yeah, isosceles triangle. Where'd you go, Elion?
I wasn't here.
That's all right. I like that even better.
I lived in California.
Really?
Yeah.
When'd you move here?
Last year.
Wow. How's the adjustment been? Good? You like it here?
Yeah.
Now, were you in California your whole life and then moved here?
No.
No?
I lived here for like a year and a half.
In California?
Yeah.
Where were you before then?
Michigan for 9 years.
Wow. So you're cross-country traveler.
Yeah.
Wow, that's awesome, though. That's awesome. What was your best spot, you think, so far? You don't have to say here. I don't care.
California.
Was it? Because weather, good weather? We're in California.
Bay Area.
Nice. One place I'd like to go that I haven't been. So out there. No snow out there, huh?
Yeah.
So what's it like in like February, January?
Like maybe 30s. It's not that cold.
Any snow whatsoever or no?
Nope.
Never saw a flake come down?
Yeah, there was wildfire stuff in like October.
So how do schools operate? Do they start in August?
Yeah. They start in August.
Yeah.
And then
Get out in May?
early June.
Okay. Regents exams or anything like that?
Not in the middle school.
No. Same structure like K-5, elementary, 6, 7, 8, middle?
Yeah.
Yeah. Cool. Nice. All right. That's awesome. Other questions? For me, not for Elliot. I'll do the questions. Thanks. All right. Every year I debate whether or not I should give this class the next proof. And I decided to this year because you guys have been pretty decent here with your academic and math ability. So why not try to give you a real tough one now? See what you can do with it. I say real tough, but I might be overdoing it. Yes. Yeah.
You already done the homework.
Well, why don't you check if you have the right answers or not? Because how do you know if you're right or wrong, right? And it looks like I marked everything for you, huh?
Yeah.
All right, go through the givens. What? Because you never know. I might be feeling soft, and I gave you some info that makes life a little easier. 1 and 9. What can I count? I can count those at angles. Yes or no? Yep. All right. I gave you a pair of angles. A, B, and GF. Did I give you a pair of sides? Can I count those as a pair of sides? Nope. Am I really? I might be over exaggerating there, because I already gave you 2 out of 3. That third pair is going to be a little tougher than you think. So is everyone all right? I gave you 2 pair, an angle and a side. We're on the hook for the other pair. All right, let's talk about this given right here. It's saying CDE is isosceles and the base is CE. The base was from yesterday's vocabulary. The base was the side that is not congruent to the other 2. So this given is really saying what 2 sides are equal up here. If CE is the one that's not congruent to the other, this given is saying that which 2 sides are equal. CD and DE. That I don't have to write that in my proof. That's given to me by saying that base CE. Right? I don't have to write that. So hopefully that's why we need to know the vocab. Oh, that's the base. That's the non-congruent side. The other 2 are congruent. All right, let's go. From here, I got 9 angles labeled here, right? Where do you want to go from here? Where can we go? Another true statement. 7.
4 and 6 are congruent.
4 and 6. Everyone agrees. And a triangle. Congruent angles are across from congruent sides. Keep going. What else? Because I need 2 angles in these 2 triangles. What else is congruent? 8.
2 is congruent to 4.
Yep.
6 is congruent to 7.
Yes, but here's the thing. I'm going to put those in separate steps. I'm only going to do one of the vertical angles because I'll tell you why as we move along. So I'm just going to say 4 congruent to 2, and that's it. I know the other pair of verticals are equal, but I'll do that in a second. Vertical angles are congruent, and I'll show you why. Look at what I just wrote right now. Look at the last 2 steps that are on your paper. 4 and 6 are equal. 4 and 2 are equal. Got 2 other angles that have to be equal now that you can't see on the diagram? 4 and 6, 4 and 2, and 7. What does this tell me? 4 and 6, right? And 4 and 2.
Then
2 and 6. Good. You remember what that was called, Kier? What you just did in your head? Yeah, you do. You took 2 and in for 4.
Substitution.
There you go. Substitution. Now go back. So if it was the other pair of verts you just told me a couple minutes ago.
6 and 7.
6 and 7, yes. So here's why I'm doing these in separate steps, the vertical angles. This is a 2 substitution proof, not 1 substitution, 2. Okay, and if you guys put both vertical angles in the same statement, you would only write substitution once, unfortunately. But it's actually 2 times you need to use it. And speaking of that second time, 2 is congruent to 6 in step 4. 6 is congruent to 7 with what we just wrote. Name 2 other angles now that have to be congruent. 1, if 2 and 6 and 6 and 7 are equal.
2 and 7.
2 and 7, and look where they are in the triangles we are proving congruent. There's your second substitution, kids. Whew, they are getting rough. And then there's your third pair. You guys have to look at your diagram now. Is this angle side angle, or is this angle angle side? That's what you have to decide right now. Bless you. Which method here? Is that side in between or not? 8.
Angle, angle, side.
Angle, angle, side. That side's not in between. Good work. Questions? Okay, here's what we can do now. Flip it over. You're obviously going to start the assignment, but if you think you're done, let me look at it, please. Okay, let me look at your proof. If you are stuck, maybe you can't find that last pair of corresponding parts, let me look too. Let's all start this homework, this first one together. What's the proof statement say? What are you looking for in the proof statement? Angle Q congruent to S. Remember what we've been talking about. The angles aren't congruent unless the triangles are congruent. So at the end, this is going to be a CP-CTC proof. All right, but you got to get the triangles congruent first that contain Q and S. So those two overlapping ones. If you get stuck, let me know. If you think you're done, let me know so I can look at it.